All right, you guys, today we're looking at chapter 4.3, contingency tables and Venn diagrams. So first up, we're looking at mutually exclusive events. So I'm looking at event A and I'm looking at event B, and I see that these two events, they do not have any outcomes in common. There is no overlap between them. All right, so mutually exclusive are events, they have no overlap. There are no shared outcomes, no outcomes in common. And if we look at something that is inclusive over here, we see that these events do have outcomes in common. We call this space right here the overlap. So for example, let's say that I make a hypothetical. Let's say that I am picking a student on campus and I'm looking at a student who is in 9th grade or in 11th grade. So would those be mutually exclusive or inclusive? Can I have a 9th grader who is also in the 11th grade? Right? Not possible. There's no overlap there. Those would be mutually exclusive. If instead I say we are picking a student in the 9th grade or a student who's on the swim team, well, we have 9th graders who swim. We have some overlap there. Those events would be inclusive instead. So right in this space here would be the 9th grade swimmers. Over here would be my 9th graders who are not swimmers. And here are my swimmers that are not in 9th grade. Okay, so in example 1 now, let's quickly decide, are the events inclusive? Do we have overlap? Or mutually exclusive, no overlap? So rolling a die. So event A is rolling a 3, event B is rolling a 4. So can I roll a 3 and a 4 at the same time? No, I cannot. So these are mutually exclusive. There is no overlap between them. It is not possible to roll a 3 and a 4 at the same time. All right, for B, select a male student and then select a drama student. So can I have a male drama student? Absolutely. So these would be inclusive events. We have overlap. All right, blood donor. The donor's blood is type O, and the donor is a female for event B. So can I have females with type O blood? Absolutely. Again, inclusive. Because we have overlap, we can have females who have type O blood. All right, so this brings us to the addition rule. So the addition rule for the probability of A or B. So whenever we see that word or, that should trigger for us that we're looking at addition. We're saying this could play out or this could play out. So if I'm looking at A and B are mutually exclusive, then I'm looking at the probability of A or B. I could just add those two probabilities. I'm adding the probability that's here to the probability that's here. So I can add straight across. Okay, but if my events are inclusive, well, then I have to start with getting the probability of A. I'm going to add it to the probability of B. Let me stop there for a moment and kind of show you the issue. So here is the probability of A. And then I have the probability of B. And I see the issue is, oh my goodness, I'm double counting this region right in here. So what I need to do is I need to add the probability of A to the probability of B and then remove the overlap. I don't want to double count the group that's in this shared space. So now I have to subtract the probability of A and B. This is our overlap. And we don't want to count twice. I'm going to write that as don't double count. So if I go back to one of those examples above, say I'm looking at selecting a male student or a drama student. So over here I would capture all of my male students. Over here would be all of my drama students. And those that fall into this region here would be counted twice. So I want to make sure that I don't double count. So I subtract the overlap so they're not counted twice. Those male drama students, we don't want to count them twice. All right, let's do an example right here. So according to a recent survey, 120 Redwood High School teachers were asked if they prefer a double block schedule and if they support an advisory period. We have 67 Redwood High School teachers who prefer double block. We have 50 who support advisory. We have 44 Redwood High School teachers who prefer double block and support advisory. Organize this information in a Venn diagram, and then imagine if one Redwood High School teacher is selected, what would be the probability of each event down here. So the D says, oh, we just love the double block, and A, we support an advisory period. So when I fill out my table here, I have to work inside out. And I'm always conscious of, well, how many bodies do I have to work with, right? I got 120 total Redwood High School teachers. So I'm just going to put a 120 right up here. All right, so then if I read through my details, we have 67 who prefer double block. We have 50 who support advisory. And we have 44 who just like both things. Okay, so working inside out, here are those 44 that are the overlap. They like the double block, they support advisory as well. So now let me block this out like that. I know that 67 total prefer the double block. So everything in this space has to add to 67. So if I take 67 and I deduct 44, I'm left with 23. So I have 44 teachers who like both things. These 23 only prefer double block, but they do not support advisory. Okay, we have 50 who support advisory, so let me block this out. So in total, everything in this circle has to add to 50. So if I take 50 and I subtract that 44, I have 6 right here. So 44 support both things. These 6 only support advisory. They do not prefer a double block. All right, so now where's my leftovers? I have 120 total Redwood High School teachers. So if I subtract the 23, the 44, and the 6, I'm left with 47. So by making a Venn diagram, I'm able to see the 4 different ways this could shake out. We could pick a teacher who says yes to both things, in this context, double block as well as advisory. I could have one of these 23 teachers who only like double block, but they do not like advisory. These 6 teachers, they like advisory. They do not like double block. And these 47, they don't like either. They're saying no to both things. They don't like the double block. They don't support advisory. Okay, so now answering some questions. Find the probability of D. So find the probability we pick a teacher who prefers double block. So here I'm looking at anyone in that circle, anyone who likes that double block schedule. So 67 out of the total, 120. Okay, next, find the probability that we are picking someone who does not support advisory. That little sweet baby C means complement. So we're looking at does not support advisory. So if I look at who supports advisory, right, that would be these 50 right in here. So I want to go through the complement. I want to go 1 minus all of those who do support advisory, like this. So 1 minus those 50 out of 120 who support advisory leaves me with 70 out of 120 who do not. And when I reduce that down, I get 7 out of 12. All right, next I'm saying find the probability of D and A. So when we phrase it like this, right, we're picking one teacher at random and we're looking at someone who likes double block and advisory. So this is really saying find the overlap. So the overlap is right there, the 44. So I have 44 who make up the overlap out of 120. Reduce that down, and that's 11 out of 30. All right, and then here is the OR. So the OR here, we're looking at a situation that's not mutually exclusive, it's inclusive. Sorry, we have overlap, right? We have overlap because we have teachers who prefer double block as well as advisory. So there's really 2 ways we could approach it. We could approach it from the Venn diagram. And in the Venn diagram, we're really looking at these 3 numbers. And from the Venn diagram, that double count, it's already taken care of. So if I go from the Venn diagram, let me just abbreviate like that, Venn diagram, I could add up the 23, the 44, and the 6, and divide by 120. I would get 73 out of 120, which is fine. That would work. I could have also gone through the complement, right? I could have done 1 minus that 47 out of 120. That would have worked too. Let's pretend that I didn't have a picture of it though. Let me block this out of view. And let's say that I prefer to follow the structure of the problem. And I'm looking at the probability of D or A. So remember, that's looking at the probability of double block plus the probability of picking teacher who likes advisory minus the overlap, double block and advisory, like that. So again, I'm ignoring my picture. I'm going straight to the structure. So if I'm here, then I could look back. I have the 67 that prefer double block out of 120. Okay, advisory. Here we have the 50 who support advisory out of 120. And then we have these 44 teachers who say yes to both things. And they are being included in this group and this group. I don't want to double count, so I'm going to deduct the 44 out of 120. So when I take 67 plus 50 minus 44, I'm back to 73 out of 120, but a different way of getting there. So some of you might like the Venn diagram approach. What's helpful about that is it's already taking care of the issue with the double count. And some of you might be creatures of habit where you like having a structure, and this might be the way that you approach it. Either way, we get the same end results. All right, let's look at the flip side. Okay, so here in example 3, a 2015 survey suggests that 52% of U.S. teenagers use Instagram, 33% use Twitter, 20% do both. Organize this information in a contingency table. It's just a two-way table where we're looking at two variables. So we're looking at Twitter and we're looking at Instagram. Now, if we pick one teenager at random, we want to find the probability of each of the following right here. Okay, so what I'm going to need to do is first fill out my table here, my contingency table. So here, first, I'm going to look at the overlap. 20% do both. So 20% say yes to both things. 20% goes right here. Okay, we know that 52% use Instagram. So here's my Instagram. We're saying yes. So 52% would go right here. And we have 33% use Twitter. So yes to Twitter, 33% right here. We know that our grand total should be 100. All right, so I put those numbers into my table and then I need to fill in the rest of it. So here I know that this column has to add to 52, so what's missing? 32% here. Okay, this row has to add to 33, so 13% right here. Okay, if I go here, this row has to add to 100, so I need a 48 right here. This column has to add to 100, so a 67% right here. So what's missing, the cell right here, I can get at it two different ways, right? This has to sum to 67, this has to add to a 48. So either way, this needs to be 35%. So I have filled in my contingency table and now I have a few questions. So we're saying find the probability that we pick a teenager who uses Instagram and Twitter. So here we're saying, well, that's yes to both things, 20%. Yes to Instagram, but not Twitter. So yes Instagram, but no Twitter, right there, 32%. Yes to Twitter, but not Instagram. So here we're looking at this right here, that 13%. Okay, not Twitter, not Instagram, no to both things. That would be the 35% right here. And now we see the or. So in the or, what's nice about the contingency table, right? If I'm saying Instagram or Twitter, they could like just one of them, or they could like both of them. So I could add up these three parts right here. So if I add up the 32, the 20, and the 13, that would get me 65%. Let me show you this way. So from the table, I can add the 20, the 13, and the 32 to get me 65%. So what's nice about the table, it's no problem with a double count. Okay, or I could follow the structure. Let me block this out of view and follow the information that's provided. So Instagram or Twitter. So I could look at the probability that they use Instagram plus the probability that they use Twitter, and then subtract the probability of Instagram and Twitter. That is the overlap. So Instagram, 52%. Twitter is 33%. But those 20% that do both, they're being double counted. They're counted here and they're counted here. So we want to make sure we don't count them twice. So here I have my 85 minus 20, and I have 65% a different way. So again, by using either a Venn diagram or a contingency table, right, I can see my information very clearly and I can get to my answer pretty easily. Or I could follow the structure of how I calculate the or situations, where I'm saying, okay, I can add these two probabilities and then account for that double count. I don't want to count things twice. All right, next up, now I'm showing you some formal notation. Let me write it out for you right here where I have space. So if I show you a U like this, that means union. That means or. Right? That means that we're going to add scenario A to scenario B. And if we see it upside down, this means intersection. We can also use the word and in this context, we're saying this is the overlap. All right, U for union, that means or. Upside down U reads as intersection, that is the and. It represents our overlap when we're picking one thing. All right, next example. So in a large apartment building, 35% of residents read Us Weekly, 25% read Time, 10% read both. Suppose we select a resident at random and record which of the two magazines the person reads. Make a Venn diagram to display the sample space, calculate each probability. So for each of these, I'm just going to fill it out first. So I know that 10% read both, so I'm going to put my 10% in here. Okay, I know that 35% read Us Weekly, so 35 minus 10, and I have 25% here. Uh, 25% read Time, so here should be 25% total. Take away 10, I have 15 here, represents 15%. Okay, and then what's my leftover? So what's left over? So if I take 100% and I subtract 25, 10, and 15, I'm left with 50% in this space over here. These people, they don't read either one. Okay, so now just reading through A. So A, we see this upside down U, right? This means intersection. This means overlap. So I'm looking at US Weekly and Time. I'm looking for the overlap, those people who read both magazines. So I'm looking at the space right here, which would be 10%. So 10% read both Us Weekly and Time magazine. Okay, here we're saying, well, what if they read exactly one? So only one of them, not 0, not 2, only 1. Well, that's looking right here. So these individuals in this little crescent moon, they only read Us Weekly. And then over here, these ones only read Time. So I'm looking at, well, what is 25 plus 15? So 40% read only one magazine, read only Time, or read only Us Weekly. Okay, next, reads at least one of the two magazines. So that's saying it could be 1 or 2. So another way that we could have phrased that is we could have said, well, what's the probability that they read Us Weekly union with Time? Or. So if I take it from my Venn diagram, we're saying, well, these are the ones that read only one magazine. And these guys in the middle, they read 2. And when I have it laid out in my Venn diagram, I don't have to worry about a double count. So I can just add these up and get to 50%. Okay, but if you like the structure, if I go back to the details, I could add the 35% that read Us Weekly to the 25% that read Time, and then subtract the 10% that read both, and I get to 50% as well. Okay, and then lastly, reads neither magazine, right? Reads 0 of these 2 magazines. So here we're looking at the space between the rectangle and the circles. So right back in here, 50%. All right, one more problem. All right, out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What's the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So I'm a structure girl, so let me lay out the structure here. We know that the probability of being a varsity athlete or on the honor roll, give my nice little U notation right there, is equal to the probability of being a varsity athlete plus the probability of being on the honor roll minus the probability of being a varsity athlete and on the honor roll. I've used my upside down intersection notation there. So I know my structure. So let me read back the details. We're given the or here. So the or is 113 out of 200. We have 74 who are varsity athletes. So 74 out of the 200. Okay, honor roll. We have 51 who are on the honor roll. So 51 out of 200. We're solving for the overlap. We're solving for the and. I will call that x. All right, so now I see my equation that I've built and I'm just trying to solve it. So 113 out of 200 is equal to, if I combine here, I have 125 out of 200, take away x. All right, I have my common denominator, so I'll take away the 125 over 200 from both sides. So that gets me a negative 12 over 200 equals negative x. Okay, well, I can divide both sides by negative 1, so I would get x is 12 out of 200, but I would reduce that down. I always simplify my fractions, and those are both divisible by 4. So if I divide 12 by 4, I get 3, and 200 by 4, I get 50. So my reduced fraction, my probability of finding a varsity athlete who is also on the honor roll, varsity athlete and honor roll, is 3 out of 50. So in this problem, we had to solve for the overlap. We were given the or. So we were given the or, we had to find the and it became all about structure. All right, have a good rest of your day.